quick. Graph y equals the opposite of f of x, given the graph of y equals f of x here in blue, by hand 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. So the first way is we're going to reflect this about the x-axis, because we do know that a function and the opposite of it is reflected about the x-axis. They're symmetric about the x-axis. So we have the sketch of f of x kind of light right here. We're going to select key points on function f. So we're going to select these points right here. 1, 2, 3, 4, 5. And we're going to reflect each of those points about the x-axis. And remember, that means they're going to be the same distance away from the x-axis, but in an opposite direction. So right here, that's the distance going in the opposite direction. There's the point on the opposite of f of x. This point is on the x-axis, so it stays. 1 unit there, 1 unit back. 3 units down, 3 units down further. And 3 units down and 3 units down further. So we're going to connect the points to finish the reflection, make sure you have straight lines, but this is kind of an arc right here, so we have to make sure it's like that. So draw that in the best we can. And so here's the graph of y equals the opposite of f of x. Comparing that to the parent function, we can see that, yes, they are reflections about the x-axis. Using a table, very similar, we're going to identify the key points on the graph and put them into a table, the coordinates into a table. So that point right there, and we'll just go ahead and record those ordered pairs into the table. And now I'm going to create a second table for y equals the opposite of f of x. And we're going to use the same x coordinates, but the opposite for each y coordinate. So negative 3, 2 will go negative 3, comma negative 2, and I'll plot that one. Negative 1, 0 stays the same. This one goes to 0, negative 1, 1, negative 3, and 3, negative 3. And now connect the points using the original function, again using straight lines and arcs where I need to. There's the graph of y equals the opposite of f of x. And as I did before, we'll compare it to the parent function and see that they are symmetric, or reflections about the x-axis.